It sort of strikes me that when a lot of people kind of a little bit freaked out by AI and the prospect of it, you seem rather excited.
Absolutely. Obviously, everything needs to be used safely and with caution. We're at this, into this new space. So who knows what information could be used for. So as long as it's used safely and wisely, then the power that it has is just absolutely incredible and is transformative for any organisation.
Hello and welcome to WSP's Positive Impact Podcast. I'm your host, Lucy Siegle, and this series is for anyone who's curious about how innovation and sustainability are shaping the future of our cities, industries and environment. Today, we're exploring how data science and artificial intelligence, AI, are transforming infrastructure across sectors like transport, energy and water, helping organisations unlock insight from vast amounts of data to inform long-term planning. This episode focuses on the water sector, where Ofwat's regulations are driving companies to use AI-powered adaptive planning to better prepare for the challenges of today and tomorrow. Now, joining us are two leading voices in this space. Dan Scott, Chief Data Scientist at WSP, who specialises in using AI and data science to deliver smarter, more resilient infrastructure solutions, and Dr. Angela MacOscar, Head of Innovation at Northumbrian Water, whose work is focused on embedding innovation within the workforce to drive sustainable outcomes. Dan, Angela, welcome to you. Thank you so much for joining us.
Thanks for the invitation.
You're welcome. Now, you are both fascinating people and you've got so much experience. I'd like to start with a big question. So across sectors like transport, energy and water, innovation, including AI and data science, are already transforming infrastructure. But what I want to know is what that actually looks like in practice. Dan, let's start with you.
AI is applied in quite a few different ways in different sectors. So anything from applying it to kind of understanding the current condition of an asset through things like image recognition, through sensor networks and understanding the signals that are coming back from those, and kind of understanding whether or not that is suggesting that there's an issue with the asset or anything like that. But even through just down to kind of access to knowledge and information for engineers and technicians out on site. So the ability to very easily ask a question and find out what the standards or documents or instruction manuals for assets actually tell them about a particular problem and that sort of thing. So it's really about helping engineers to kind of home in on what are the problems, what things should be worried about, what things need fixing and repairing, and that sort of thing. So quite a broad range of different applications.
Okay, and I'm sure we'll come back to that. We'll find out maybe how the engineers like using it and are they using it. Angela, let's come to you. Where do we sort of see it working in practice?
So at Northumbrian Water, we really have embraced digital and embraced these tools. And indeed, it is our aim to be the most digital water company. And we, over many, many years, have been gathering data on our assets and all of the across every part of our business. So we are sitting on such a huge amount of data. So now these artificial intelligence and machine learning tools are enabling us to actually mine this data to drive greater insight. So as Dan had said, so it's really helping our people in plants make sure that we're using energy and chemicals efficiently. It's helping in our customer teams better serve our customers, because at the tip of their fingers are the right answers for the people who are calling in and needing assistance. And we definitely saw a huge uptake of adoption during the pandemic, when we were all home based, because we needed to find ways to enable our workforce to still serve customers, but in a way that was safe. And obviously efficiency, my goodness, with the advent now of all of these ChatGPTs and co-pilots and Geminis, we're all able to do our jobs much more efficiently.
It sort of strikes me that when a lot of people kind of a little bit freaked out by AI and the prospect of it. You seem rather excited.
Absolutely. Obviously, everything needs to be used safely and with caution. We're at this, into this new space. So who knows what information could be used for. So as long as it's used safely and wisely, then the power that it has is just absolutely incredible and is transformative for any organization. So obviously, being in innovation, we love new things and we love trying new things. So we have really embraced AI.
Okay, well, it sounds like the water industry is leading the way when it comes to utilising new technology like AI, not exclusively just AI. But what are the challenges it faces? And conversely, tell me about some of the successes that make the sector stand out, in your opinion.
So obviously, culture is always one of the things that perhaps holds back people from embracing new tools, new innovations. So giving people the right information so then they can use these tools correctly and also really embrace them and perhaps remove any fear, because I think that there probably was a narrative out there that everybody was going to lose their job because the robots were going to come and take over and do jobs. That is not the case at all. We will use AI-driven tools for efficiency, but what this does is it actually takes the repetitive repeat tasks off people, so then we can actually then upskill them to do more higher value added tools. So actually it's better for employees and actually better for the business. So actually I see it as rather value add rather than a diminishing opportunity. And in terms of some of the examples of how we've used AI, so as I said, we're really transforming how we're running our plants, because we have all of this data and it is able to predict and recommend what we do in a much more data-based way than a human can. So we have so much data that we really can mine this to make sure then that we're using energy and chemicals more efficiently. We can also pass on knowledge. So in our sector, we have a bit of a grey tsunami coming. Everybody is, getting to that age where they will be coming up to retirement. And these people know the operation and the plant so well that all of that knowledge is going to walk out the door. So we're going to be using these AI tools to actually collect that knowledge, so then it's not lost and we can still run our operations efficiently with the benefit of that incredibly, accrued knowledge over 30, 40 years.
Wow. Grey tsunami. I haven't heard that phrase before, but I like it. I guess I'm part of it. Dan, what do you think? You're nodding to a lot of that.
Yeah, I think one of the key things to remember, so if you look at decision science, which is the kind of study of how decisions are made and that sort of thing, it's always interesting because it splits into two very distinct branches of study. So one branch is the kind of mathematical study. What's mathematically provably the correct answer to a set of problems. The other branch is effectively can be summarized as why as human beings do we not make the same decision? And a lot of that comes down to the kind of psychology of it. As human beings, we're actually not very particularly good decision makers. We make decisions based on emotional responses and that sort of thing, rather than data and factual things. So we tend to kind of shortcut a lot of our decision making processes. The reason that AI and data science adds so much value is because it starts to bring some of that kind of structure, logic and rigor into that space to inform some of those decisions. So just having access to data in itself, everything in the world produces data in terabytes. Just funneling that through to an engineer and expecting them to suddenly make vastly better decisions as a result of that torrent of data is naive, because that's not how we make decisions, and we can't consume that fire hose of information, and we can't do anything with it that's particularly effective. AI provides that kind of ability to process that and kind of turn that into something that is a little bit more easy for us to kind of interact with, and therefore understand what is it telling me, what is the recommended decision that it's trying to point me towards, and do I agree with it, and those sorts of things. And that's where it becomes transformational, because it is kind of converting the world of the data, logic, and that sort of thing into a human decision to do something, which is the bit that drives the value.
It's so fascinating, and it's sort of quite a sort of creative understanding of how it works. But there are drivers, aren't there, for this change? And I'm wondering, if we say the water industry is ahead when it comes to adaptive planning, where is the place of regulation? So we know that Ofwat obviously driving regulation, and is that also driving and influencing this sort of change?
Absolutely. I mean, so adaptive planning it kind of flows out of a very specific problem, which is that, historically, when we're kind of dealing with uncertainty, we kind of fall into this sort of cognitive fallacy of saying, okay, well, let's, given that we don't know what the future looks like precisely, let's work out what we think is the most likely way that the future looks. And then let's kind of work out the plan of how we respond to that most likely future. Now, there's a danger with that kind of that we kind of over optimize our plan. So we kind of go, I'm now going to come up with the most cost effective value for money plan to deal with that most likely future, which is great, except when the future turns out to be a little bit different to that most likely scenario. And what happens then is you then have to go, oh, okay, I need to suddenly adjust course and do something quite different, and that quite different could be very different. So it could be the difference between I need to build an enormous great new reservoir versus I just need to tinker and sort out some leakage in some pipes, or something like that. And that could be a drastically different sort of plan that we need to implement. So where Ofwat came at this problem was sort of saying, okay, well, actually we need to worry about all the different ways the future could unfold, and we need to work out what's the most likely plan we need to deliver if we need to protect ourselves against all those potential futures, and how do we make that good value for money. So that's where adaptive planning was born out of. Effectively, Ofwat worrying about, okay, what happens if we suddenly realise that climate change is really, really bad? If we suddenly see a big surge in population growth in some of our kind of major centres, what if there's massive shifts in technology and technology uptake and other bits and pieces, and it changes the demand for water? What then? And what Ofwat are trying to avoid is, suddenly kind of getting to a point where all the water companies are going, oh, hang on a minute, we need to drastically 180 our plans, and we need an awful lot more investment, which means an awful lot more cost going to consumers, and that sort of thing. So they're trying to, they've introduced adaptive planning as a requirement purely to kind of force that thinking in and say, okay, I want you to optimize your plans, but I want you to optimize them against a wide range of different possible futures, and think carefully about those decisions and which points, which things you do now, which things you wait until you have more information and pivot later on, and how do you kind of create that plan.
Okay, Angela, so I'm sort of building up this idea that this AI-driven scenario planning is really helping, leaders to lead, essentially. How do you kind of square it? How do you consider it? And what do you think it's driving?
So I think that what Dan was saying is exactly right. So we would not have the capacity to run the almost infinite number of scenarios that the future could potentially hold, whereas AI can do that in almost like, I want to say, the blink of an eye. It's probably not quite. But it can do it a heck of a lot faster. It can also intake so many different sources of information in order to come up with these different solutions, that it's actually really helpful when we're considering asset planning, workforce planning, and really enabling us to have a bit more of a longer term view, which is what we need to have. So historically and still currently, we have our asset management planning cycles, which are on a 5-year basis, but that is a very short window of time. We need to be having much longer term plans, especially when we're taking into account the impacts of climate change, population change. That all happens over a much longer time frame. So this power that we have now because of the AI and machine learning tools enable us just to run many, many more scenarios and to be a little bit more flexible in our planning, which is something that we definitely need to do.
Dan, can you give me an example of adaptive planning?
Yeah, okay. So if we take the water sector as a very specific example, so every 5 years they have to produce their plan for the next 25 years of what they're going to invest, what they're going to build, and that sort of thing. And the underlying principle there is you need to manage the supply-demand balance of water. So you need to make sure there is enough water coming into the water network to there's a minimum balance the amount of water that people want to take out of it in terms of switching on the tap. Now, the way that you can achieve that, the things that are going to drive changes in that balance over time are things like climate change. So if climate change results in a hotter, drier climate, then people are going to use more water to drink, but also to water gardens and things like that. But it might result in a hotter, wetter climate, in which case actually there's going to be a lot of water coming into the network via reservoirs and those sorts of things. So that's a very different looking outcome. Things like population change, that's something, more people use more water. So there's lots of different possible outcomes that the future looks like that you're trying to plan against. And there's lots of different things that you can do to try and resolve that supply-demand problem. So I could go in and I could fix a load of the older pipes that are more likely to be leaking and losing water into the ground rather than getting to the taps. And that way, if I lose less water, there's more water available to be used. So that helps my supply-demand balance. Other options might be to build a new reservoir or a new water storage facility or something like that, which allows me to store more water and therefore have more available to use. So the question then is, okay, which of those things should I do? The pipe type work is generally a lot cheaper. Water companies do a lot more of it. There's a lot more kind of certainty about what it's going to cost, but there's still some uncertainty about precisely how much water is going to be saved by doing that. How much leakage does it actually reduce by? So when you're considering those different ways that the future could unfold, in some of those features you say, okay, I could just get away with just doing the leakage stuff. I could just, and a few kind of minor tweaks and some, encouraging people to use a little bit less water, some exercises in local schools where we kind of educate people in water usage, has an impact on demand and it improves the balance. And if the future is fairly kind of benign and friendly looking, then that might be more than enough to keep the supply-demand balance under control. The problem then is, okay, what if I end up in a very hot, dry future? That's not going to be anywhere near enough to solve the problem, which then brings you back to the big, expensive schemes such as the reservoirs and things like that, where you kind of go, okay, well, that would definitely need a reservoir potentially in that example. So that's the adaptive planning question then comes to go, well, okay, if I understand all those different futures, all the different ways that might look, and the uncertainties around exactly how much water am I going to save from reducing leakage and everything else, should I build the reservoir? I know it's going to be more expensive than just fixing the pipes, but actually, does it protect me against more futures? And does that mean that I can spend less on some other things, but then bring those back in if I feel that I need them later on? So if I could, what adaptive planning then searches is it better to build the reservoir now, have that there, kind of deals with the kind of base load of everything you need, and then if you suddenly realise the future's even worse, then I can go in and do the school demand schemes and other bits and pieces that I might need to do to kind of further layer on. But those are things that I can add in later on. I don't, a reservoir has a kind of 20-year planning and lead time to get it into place. A school scheme, 6 months, 1 year, so I can mobilize that much quicker. And that's the art of the adaptive planning. I sometimes refer to it as spread betting against the universe. You're trying to work out, okay, well, how do I put these components together in a way that means I'm always as well positioned as possible for whatever the future might throw at me.
Another great phrase, spread betting against the universe. We'll have that. Thank you. Okay. So when we're thinking about a more sustainable future, and you've both referenced climate change, for example, how can AI and tech help us transition to more impactful and effective solutions as we move away from traditional infrastructures? So we're making more place for greener and better for society and more sustainable solutions overall.
So this is a really interesting topic area, because often it is the default that we just go with what we know, which is to pour grey, to do concrete, and to probably make decisions that are cost effective, easy, and the ones that we can flip to. Whereas that is not the way that we want to have our future. And we are very much wanting to add nature-based solutions into the mix. They are incredibly effective, but we are still in our infancy, I would say, in really understanding the longer term impact of these particular interventions. And this is where the likes of AI can come in. So we have a number of really exciting projects underway at the moment where we are using AI and machine learning to create models that have lots of different, very complex inputs to understand what would that nature-based solution impact be in 10 years, 20 years, 50 years, and have a dial where you could really understand the impact based on the data that we have today. So AI is unlocking the potential to de-risk these nature-based solutions. So we have that project underway at the moment. We also have another project where we're looking at how we can understand river water health. And again, using AI and ML-driven models, we're able to understand on a whole catchment basis where the sources of pollution are and what we can alter in order to promote river water health. So we would never have had the computing power before to actually do this on the scale that we can today. So it is really unlocking, I think, the key to a more sustainable future.
Wow, this is a whole new vista for me. Dan, give me some more real world examples if you've got any, because we love those examples.
Yeah, absolutely. So I think just to build on that, it is really the value of AI is about exploring things that we wouldn't be able to explore and on options we wouldn't be able to explore otherwise. So we can handle all of these data points, and we can take these quite complex kind of knotty problems whereas traditionally we might kind of go, okay, well, here's the kind of engineer's preferred solution, and then we might force them to kind of come up with another one or two solutions, but they're kind of, because they're forced to do it, those solutions are kind of generally not as well thought through and considered. That
very diplomatic.
But what we can do with AI is kind of actually just give it a description of the environment, the context, the world that the problems that we're trying to solve, and let it kind of explore a much more complicated sort of decision space in terms of options, and then make suggestions back, and then we can kind of decide, as human beings, what we like, what we don't like, and we can explore some of those in more detail. But what it's doing is really shortening that feedback cycle between kind of let's come up with some ideas. Those ones we like, those ones we don't. Let's explore those in a little bit more detail. Let's simulate out what that looks like over time. All those sorts of things. Outside of the water sector, you've got various other kind of environmental impacts. So things like planning for offshore wind. Obviously we know that we've got to undertake a major energy transition. Where you're going to put your wind farms and that sort of thing. That's a complex set of decisions, because it's not a zero impact decision. Some people don't like the look of them if they're on the horizon. If I sort of choose an area of the North Sea to plonk a wind farm, that might actually have environmental impacts in terms of migrating birds. It might have impacts in terms of kind of particular local fish and other bits and pieces. I have to consider how to actually connect that to the grid, and whether or not the energy that I'm actually generating there can actually be usefully used within the grid. So these are all sort of spaces that that where we have quite high levels of uncertainty. There's quite a high level of complexity to that question, and we can use AI to kind of really explore some of that and go, okay, well, is it a good idea to put it there, or maybe we should put it several miles further down the coast. Maybe we shouldn't put it out at the sea at all. Maybe we should put it on the land. We can kind of explore these questions in a slightly less emotional way.
Yeah.
To kind of actually understand the consequences of these decisions in a little bit more detail and a much greater granularity level, before we then bring the emotion back into it and go, okay, but which ones do we like? So it's about kind of there's lots of those sorts of examples where we kind of AI is being actively used to inform the debate, I guess is the best way of thinking about it.
And is it proven? Do you think, are there contexts where it's proven that works? So you've given an example of the North Sea, for example. I'm wondering, is it being used in that context, or is that something that still we need to make a case for? Yeah,
I mean, so remember that AI is a broad umbrella. Of terms, so we kind of naturally because of the sort of media coverage and that sort of thing, we talk about AI, and people kind of tend to gravitate towards the chat GPTs and large language models and that sort of thing, of which of course they are an AI. But here there are various other types of AI that have much greater pedigree, if you like, in the field. So in a lot of what I'm describing there, you're looking at decision optimization algorithms. So they're about kind of searching options, seeking kind of mathematical solutions that are kind of optimal to a particular set of constraints. Now those have been around for far longer. They are provably mathematically accurate. So you don't have, whereas we have kind of challenges around hallucinations and other bits and pieces with large language models and things of that nature. Those sorts of AI are not prone to that. They are much more transparent and explainable, and they are provably correct, which obviously means that we can put those into those contexts and they are being put into those contexts with much greater confidence to say, okay, well, if this is the set of measures, these are the things that you're measuring to decide whether or not one plan is better than another plan, which might be I measure it across 50 different measures and other bits and pieces. If that's the way you want to measure this is mathematically the correct answer to that question. Mm-hmm. And if you don't agree with the question, it's probably because there's some other factor that you haven't articulated. So if we look in transport, for instance, so optimization of investment plans in transport's been around for a good number of years. And what happens quite often is you kind of you get all of your asset information together, all your asset needs together. You kind of then run that through an optimization algorithm to kind of work out, okay, well, given a constrained budget and various other constraints we've got in the network, which assets are we going to invest in first, and how are we going to group that together? And what often happens is you do that the first time, and then you kind of show it to the engineers, and they go, "Oh no, I don't like that plan." And you go, "Okay, well, it's mathematically accurate for the question that you've asked, but why don't you like it?" And they go, "Oh, well, you can't do that and that together because there's some reason you can't get a digger in there or something like that." And you go, "Great, okay, but you just described a constraint that the AI didn't know about. So now let's put that constraint into the AI, run it again. Now we get a different answer. Mm-hmm. Do you like that one or not?" And you kind of work through that. I sometimes describe it as the kind of Douglas Adams problem. The answer's 42, but you don't understand the question. Because it is always about the answer is always mathematically accurate, but you have to make sure that you've articulated the real world constraints properly. Mm-hmm. And if you don't agree with it, it's because you haven't told it something, or you're wrong, which is that's a difficult conversation sometimes. But so it's about just kind of working through those. But those sorts of technologies, the same as the kind of sort of image recognition technologies and other bits and pieces, much more mature. They've been around for much longer. They're much more proven in the field, and therefore there's a lot more confidence in the application of those in real world scenarios as compared to Gen AI, which is still in its infancy to some extent, still emerging, very useful, but it will take a little bit longer to find its comfort zone.
So how can we make the water sector more customer focused, and the innovation? Where do we get our inspo for how to talk to customers and sell it to them and get them to use it and think in this way?
So customer expectation has really changed. And an example I can draw on here is that when we are scheduling to go out to a customer, they don't want to take a day off work and don't know when the engineer is going to arrive. And they now have an expectation, like ordering a pizza, that they can actually, go onto a map, see exactly what part of the process it's in, where the engineer is, and know within a very short window. So we need to match those expectations, and the likes of the AI tools will enable us to be able to provide those sorts of information and updates and be a lot more clearer with customer, which is now really what people are expecting from our service. We also can take inspiration from the likes of Octopus. So they again have a very, very different way of interacting with customers on energy. I think that they've done a great job. I know I'm a customer, and that spinning the wheel that gives me, quite frankly, I don't think I've ever spun the wheel to get a great amount of points, but I'm highly engaged and I always make sure that I spin the wheel. And we need to pinch with pride and look at other companies that are, really serving their customers well, and actually really take those on board and mirror that in our sector.
Pinch with pride. I like that.
We need to do this because there is excellent work going on across our entire sector, and the Ofwat Innovation Fund has been a huge enabler for driving collaboration across the different water companies. And there is again a huge opportunity for us to pinch with pride that great work that's going on, so all of the customers across the UK can really make advantage of that investment in innovation.
Just in case that's a new phrase for people, how do we explain pinch with pride?
So basically, another sector or somebody is doing something excellent, and you, rather than feeling embarrassed or thinking, I'm not going to use that because I haven't invented it, put all of that to one side and just think, do you know what? That is flipping amazing. And I'm going to now take what you're doing and translate that and make that happen in my sector.
Nick it with confidence.
Yeah. And acknowledge where it's come from, not be shy. And say, wow, you did a great job. I want to have some of that.
Yeah, it's a vibe. I like it. Okay, great. I'm conscious of time, that I can't keep you forever. And I would really like to talk about the next generation of humans and how they interact with this. So in WSP's recent study called Shaping Tomorrow's Workforce, a study of 4,000 UK employees conducted by Savanta, you found that 70% of workers are already experiencing AI's impact on the workforce, and 84% expect AI's role to grow. So how do we attract and prepare the next generation of talent as AI changes the nature of the workplace? And I'm also interested in what drove both of you to this sector as well. Dan, let's start with you because it's a WSP study.
Yeah, okay. So in terms of how bringing people in to the sector, I think one of the key things to always remember is that most young people coming into engineering, etc., at the moment already have a good number of these skills. They've kind of grown up with it. They'll have learnt it, to some extent at university as part of their course. To various different levels. I'm not saying it's perfect, but they come in kind of with a certain skill set. The key thing for us is to not then knock it out of them when they arrive, and that's one of the key challenges that the whole sector faces, is that we're built to kind of with a very much kind of top down kind of cascade. We have kind of senior engineers who kind of train the younger engineers that come in how to do the job, but of course those senior engineers have no knowledge of this stuff. They've never used it before, often frankly worried about it, and so we need to kind of get them out of that space and get them to actually learn it themselves. And I think there's a kind of we focus on the young people. I think actually it's CPD for the older engineers we should be worried more about to some extent, so they can actually get on board with it and work out how to use it, because otherwise we're expecting young people coming into the sector to be the transformation. We're expecting them to drive adoption of these tools and techniques and that sort of thing, and it's not a fair ask. They're just starting their careers, asking them to go, oh yeah, great, can you be a great engineer but also transform this entire sector, please? It's not, I'm sure some of them would love it, but it's not a particularly fair question. In terms of my background, I think I came into data science kind of via a very kind of windy route. So I started off as an engineer. I trained as a mechanical engineer, but very, very much with a data focus. I had the benefit of an upbringing where I was exposed to kind of computer coding and that sort of thing quite extensively. So I used kind of code. I used data a lot when I was training to be an engineer, and in my first jobs as an engineer I was very kind of data focused, and because of that my employers generally just fired me at any problem that looked like it had a lot of data and nobody knew how to solve it. And that kind of brought me through kind of various different kind of career paths until I kind of realized actually what I was doing was data science and AI and that sort of thing, but via a different mean, which is and then I kind of moved into more formally into that space, working with various companies and that sort of thing, building software and data systems to solve complex problems. But I think one of the things for me was that's always been beneficial in my career is because I didn't come to data science in a straight line. So one of the things that I always feel, and I think it's really important for the sector, is to understand that it's the combination of data science AI knowledge with the engineering knowledge and the actual understanding of what you're trying to do data science on is the enabler to be able to do something much more valuable. Yeah,
that's a very powerful combination. Very good. Angela, let's hear about you, and what maybe you've got advice for the next generation. Why do you think that they would be interested in coming into this space?
So I think that the water sector is quite invisible, I think. So I don't think if you talk to people at school, what would you like to do? I want to go into the water sector. It just is.
That's rare, isn't it?
I think, and I think a lot of people that you speak to, everybody gets blown here by accident, and I'm definitely one of those people.
Oh, yeah.
But the water sector is absolutely a fantastic place to be. There are so many different jobs, and they are essentially green jobs. We do an awful lot that is very positive for the environment, for sustainability, and quite frankly, water is without it, it's life just doesn't exist. So it has to be, we want to put it on the map so young people actually want to actively come into the sector, and we're working really hard to do that. I have a vested interest to attract more women into the sector, and certainly into the science, technology, engineering and math roles. I think that we have a huge opportunity to better reflect the society that we serve with a bit more diversity within our workforce, and I think that we have a bit of job to do on that one.
Agreed.
But like Dan, my career journey is very wiggly. Certainly, there is nothing linear about my career. So, starting off as an apprentice in the oil industry, doing my PhD in the automotive industry, I then go and work in fast-moving goods. I then have my own business. I then go and work for a startup, and then I get blown into Northumbrian Water quite by accident. But boy, what an amazing sector to work in, and I'm a huge advocate for attracting more people in, and we need this. We've got a big increase in our capital spend over this next couple of AMP periods, so we definitely need to get more people into the workplace and more diverse people. So it could be from university, but I think that we need to be attracting people from all sorts of different walks of life to come into the sector.
Wow. And your own experience, I think there's a book in that, to be honest, Angela. That's a whole different conversation. Thank you so much for sharing that with us. Now, we like to round up this podcast with our positive impact question. If you had the power to change one thing today and to create a positive impact in the industry, what would it be and why? Dan, let's go for you first.
So I think going back to my earlier comment, I think my change would be to kind of force, not force, but get all engineers across the sectors, encourage strongly, mandate, but get all engineers across the sector to kind of take that time to kind of step back and actually pick up some of these tools and recognise it's not, it's something that we all need to learn and engage with and think of as a toolkit to apply to our everyday role, as opposed to something special, new or different, and kind of break through that barrier. So, because again, if we can get everybody kind of engaged with the idea of AI and stop being scared of it, back to your earlier point, it's not here to take your job, it's here to help you do your job much better and much quicker, much more efficiently, and allow you to do many more things and focus more time on the things you actually find interesting rather than the boring stuff. Getting everybody on that page would be my number one change, because that would be absolutely transformational, in terms of and really impactful in terms of the sheer volume of things that as a nation we've got to get done, and the constraints that we're under and that sort of thing. If we can get more people on that, in that space, and stop treating data science as a separate topic for someone else to worry about, that would be really, really impactful, I think.
Love it. Bring everyone together. I like that. Angela, what about you?
I would like to build a bridge across the valley of death when it comes to the adoption of innovation in our sector. So we are brilliant at the proof of concept trials. We love doing that, but I want to end trial purgatory and enable more innovation to be adopted more quickly and more sector-wide across our industry to make positive impact for our customers and for the future.
Great. End trial purgatory. I think we can all sign up to that one. I have thoroughly enjoyed talking to you, but that is all we have time for on this episode of WSP's Positive Impact podcast. A huge thank you to both of you, Dan Scott and Dr. Angela MacOscar, for sharing their insight and helping us explore the role of AI in shaping the future of infrastructure. If you enjoyed today's discussion, don't forget to subscribe and share this podcast. And of course, rate and review us on your favourite podcast app. It all helps. And for more on today's topics, check out the additional resources linked in the episode description. And thank you for listening. And please join us next time as we continue exploring the ideas and innovations shaping our world. Until then, I'm Lucy Siegle, and this is WSP's Positive Impact podcast. Goodbye.